Okay, good evening, everyone. This is Professor Grenfell's Math 12 Statistics class, and today we are resuming Chapter 9 and opening up a new section, Chapter 9, Section 2. And here we're going to be using the t-test to test the difference between two means. And this is, I guess, of importance to note that this is when we have independent samples. We'll do something different if we have dependent samples. We'll go over what that means when we get to Chapter 9, Section 3. Okay, so basically we saw in 9-1 that we get to what? Calculate a similar sort of statistic as we did with regular hypothesis test, as in Chapter 8, the previous chapter. But here it's just, there's a few more elements because we have two different populations, two different samples, two different standard deviations, etc., etc. But the good thing is in 9-1, let me just remind you, in 9-1, our test statistic was a z-score, and it looked like this. Chi1 bar minus Chi2 bar minus the projected or the hypothesized difference in the population means. So that would be mu subscript 1 minus mu subscript 2. And this is all divided by the standard deviation for that distribution was this complicated expression. Sigma 1 squared divided by n subscript 1 plus sigma 2 squared divided by n subscript 2. Now, let's clean that up a little bit like that. And there we go. Not that I'm a perfectionist or anything. So there, now it's perfect. So the only thing that's different in 9-2 is we're not given the population standard deviations. We only have the information at hand, which is the sample itself. So we have the capacity to calculate the sample mean, and then since we're not given the population standard deviation, we can go ahead and just calculate the sample standard deviation. So here to just show you how simple it is, here I'm just going to change that guy right there to a 2. So this is 9-2. I'm going to change the z to a t. That's right, we're using the t distribution once again. And then we got to be tricky here. Almost did it. Anyhow, these are, like we said, the sample standard deviation. So those sigmas now become lowercase s's. And this is the formula, this is it, to compute our test statistic when performing a hypothesis test, testing the difference between two means. The test itself and the initial sort of problem will be very similar to what we encountered in the last section. So let's proceed on with an example. So this will be example 9-4 on page 500 even. Look at that. And we'll go ahead and collect a spot for all of our pertinent information. So just kind of scanning the problem, we can kind of get a notion of what it's about. It says something about difference between men and women and the number of work absences. Okay, and then we'll fill in the details in a minute. So we've got two populations. One of them is the men, the other is the women. We're going to have two different sample means. So we'll say chi bar subscript 1 and chi bar subscript 2. I'm going to collect this information. We've got two different sample sizes, so we have n subscript 1 and n subscript 2. And then we're going to see s subscript 1 and s subscript 2. So when reading the problem, I'm going to go ahead and make sure to capture all of this information and proceed onward. So let's read the problem. Example 9-4, page 500. On the subject of work absences, a study was done to see if there was a difference, if there is a difference between the number of sick days men take and the number of sick days women take. A random sample of 9 men found the mean of the number of sick days taken was 5.5. The standard deviation of that sample was 1.23. So we went ahead and recorded all of that information, and continuing on, a random sample of 7 women found the mean was 4.3 and the standard deviation of 1.19. So 4.3 here and 1.19 here. And oh, of course, I know you're going to be picky and insist that I make it right. Okay, well, I messed up these ones. I just mixed them up. So S subscript 1 should be 1.23 and N subscript 1 should be 9. Okay, that's more like it. And we're testing this claim at a confidence level of alpha equals, or significance level of alpha equals 0.05. And away we go. Let's go ahead and go through the hypothesis test. So scroll on down a little bit and write down the claim. So for, hang on, let's back up. For step 1. Step 1 is we write down the hypotheses and identify the claim. So the hypotheses are thus. We're going to say mu subscript 1 minus mu subscript 2 is equal to 0. So the average number of sick days that men take minus the average number of sick days that women take is 0. That means there's no difference. And then here, let's see if there is a difference. That's it. They don't have a conjecture. I was just scanning back through the problem to see if they were leaning one way or another, saying that they thought men took more sick days or women took more. They didn't say that. They just said a study was done to see if there is a difference. So that means this is going to be a two-tailed test. So if they are different, that means that their difference is not equal to 0. That means that mu1 and mu2 are not equal. All right, so following along the traditional method, we're going to find the critical values, and I always feel it's important to draw a little sketch of this. Now, I must mention the degrees of freedom. So this is a t-distribution. Remember, there are infinitely many different functions, one for each specific different degree of freedom, so-called. And so here, the degrees of freedom is whichever is less. So I'm going to say the degrees of freedom is the minimum of n subscript 1 minus 1. So that would be the degrees of freedom for the first sample. And then n subscript 2 minus 1, that would be the degrees of freedom for the second sample. So here we're going to sneak a peek back at these. So this one, the men had 9, and the women, we took a sample of 7. So our degrees of freedom, let's see, 9 minus 1, this one has 8 degrees of freedom, this one over here is 6. So degrees of freedom for our distribution is 6. And now it is hopefully clear that this is a critical t value that we're looking for. Now, it's still important to label the areas. So there's that. And on the other side, here's the same thing, 0.0250. However, with the t-distribution, finding the critical values much nicer. So, like I was mentioning, the nice thing about the t-distribution is this. All we have to do is locate our alpha value. So notice for a two-tailed alpha, we have to go to just the correct column, essentially. We have to know what type of test we're doing. So it is a two-tailed test, as our hypotheses suggest as such. And all we're going to do is go to the column that says two tails and alpha equals 0.05. Then go down to the row for 6 degrees freedom and read off the critical value is 2.447. And then on the other side of 0, we've got negative 2.447. So there are the boundaries for our critical regions, or the two parts of our critical region split into two. So moving on, we're going to now go ahead and compute the test statistic. So it's this long one. You might want to go ahead and pause the video to let me catch up. No, that doesn't make sense. Anyhow. So here is our formula for the t-test statistic. Remember, it's virtually the exact same thing, just a slight change of notation as the way that we computed our test statistic when using the z-test. Here we have substituted everything in and punch it into your calculator now. We get 1.972. All right. So if you remember, we can flip back to here. Notice our critical region began at positive 2.447, and this value is lower than that. So where would that be? That would be right here, 1.972. So we are not in the rejection region. Therefore, went too far. Therefore, we'll make the decision to not reject H subscript 0. We're not in the rejection region, we don't reject. Using the p-value method, our p-value would be larger than alpha, 0.05. Okay. Couldn't tell you exactly what the p-value was, but we can use the t-table to at least get a range for it. We can kind of trap it in between two different values. We can't know its exact size, but at least we can compare it in that way. We don't reject H subscript 0, so that means there is not enough evidence to say that there is a significant difference in the number of sick days that men take versus the number of sick days that women take. Yes. And the next thing that we'll look at is we'll maybe think about doing an example where we use the p-value method. Could do that certainly. And also we'll look at a confidence interval for the difference of means in the next video. Stay tuned.